Are there any sets for which the probability of A intersect B is negative? No. By the first axiom, whatever I plug in over here, this piece that I'm subtracting is positive, right? So we have an inequality that says that no matter what A and B are, probability of A union B is less than or equal to the probability of A plus the probability of B. Okay. Can I put something over here to the left of this? Do I know something that can't be any bigger than the probability of A union B? This is also less than or equal to 1. Sorry? P of the empty set. Okay, so somewhere way over here, I've got 0. Okay, let's draw a Venn diagram. Let's grab an eraser. All right, this is A intersect B. That's A union B. Can the probability of A is the probability of A intersect B complement plus the probability of A intersect B, right? So to get the probability of A, I'm going to add something to the probability of A intersect B. Namely, I'm going to add the probability of A intersect B complement. A intersect B complement, its probability can't be negative. Right? So the probability of A has to be at least as big as the probability of A intersect B. Similarly, the probability of B has to be at least as big as the probability of A intersect B, because I'm taking A intersect B, union some disjoint piece. The probability of that piece can't be negative. I've got to be adding something. Well, I can't be taking anything away. So I know that the intersection of the two things is only part of the union. Yes? So this has to be less than or equal to the probability of A intersect B. Right? Probability of the intersection is going to be less than the probability of the union. Probability of the intersection is also less than the probability of A, right? Because it's only a piece of A. Probability of the intersection is less than the probability of B because it's only a piece of B. Yes? Okay, so this is less than or equal to, for the sake of argument, probability of A. It's also less than or equal to probability of B. I don't know whether probability of A or probability of B is bigger. But this is true with A there. It's also true with B there. Yes?
But isn't P of A union B is exactly equal to PA plus PB?
Only if they're disjoint. The question was, isn't probability of A union B equal to the probability of A plus the probability of A? It's like, no, it's equal to this. If they're disjoint, this is 0. If they're not disjoint, I need to subtract something off. Because I've counted their intersection twice. Okay. All right, so this lets us find bounds on probabilities without knowing a whole lot else. So let's look at an example of that. Okay, so we have two events A and B. Chance of A is 95%. Chance of B is 83%. What's the chance of A union B? What do we know about it? Is it 100%? No. Okay, in particular, the Venn diagram might look like A could be here, and B could be a subset of it, right? So the chance of their union could be just the chance of A, right? But learn the trick that you guys taught me the other day. Okay, so that's not true. Is it at most 100%? Yeah, chance of anything is at most 100%. Okay, it's got to be at least 95% because when you take A and include B as well, you're certainly not taking anything away from A, right? So the chance of the union is A plus B minus the intersection. If B is already there, then, okay. So it's at least 95%. If it's at least 95%, it is at least 83%, right? That makes sense to everybody? Okay. This is, again, where people will get confused because they will think that if it's at least 95, then they don't need to answer this. But they're both true, so you have to answer them both. They have to be true, right?